It's time for Maths with Mr. Thomas.
Hi ho neighbour! Chapter 9, lesson number 2, related rates of change 1, explicitly defined rates. Now this chapter is all to do with applications of calculus. Woo! In other words, a little more differentiation and integration. You may be hit with a differentiation problem that involves different variables. And if that is the case, you will find a lot of the time that one of the variables will be time, t. The problem you are faced with may look something like this. A cylindrical tank is filled at a rate of 2 litres per second. How fast does the water level rise? So if you are hit with this, what you want to do is picture your cylindrical tank. Ta-da! And what you're told is that it is being filled up with water. And it's being filled up, so the volume is changing at a rate of 2 litres per second. But what you're wanting to find is how fast the water level is rising. So in other words, the height of the water is also going to be changing with respect to time. So in other words, as the time increases, the height will also increase. So here really we're being asked to calculate the rate at which the height of the water in the tank is increasing. So in other words, the rate of change of the height. But because that depends on the time, you can say that that will be dH by dt. And we are told that the volume is increasing. So because we are told the rate of change of the volume, well, we're told dV by, good, dt. You got it. So really we're being asked to work out dH by dt, but we're told dV by dt. And really, a problem such as this is known as a related rates of change problem. And to solve it, we use the chain rule. So what we want to do is, if we're wanting to find dH by dt, then we would write down a formula for that. And the way it's done is we split this up. So we can say that dH by dt is equal to dH by d something times d something by dt. And the best way to think about it at this stage is whatever you put into here and here in place of these stars, well, it has to be the same thing. And if it was the same thing, then it would cancel out. And it would leave you with whatever dH by dt is. To work out what goes in the star, you have to look at the rest of the problem. So let's look at this a little further with some examples. Yeah! Example 1, if V equals 4/3 pi r cubed and the rate of change of r with respect to time is 2, find the rate of change of V when r equals 3. So the best way to answer these problems is by writing down what you know. Well, the first thing is, well, we know this is a volume of a sphere and we know that the volume equals 4/3 pi r cubed. Reading this sentence, what else are we told? Well, we're told the volume, and then after that, and the rate of change of r with respect to time is 2. So in other words, the rate of change of r, well, r is going to be changing depending what time is, but that's equal to 2. So we can say that dr by dt is equal to 2. Keep on reading. Find the rate of change of V. Well, if we want the rate of change of V, again, it's going to change depending on what the time is. So we can say dV by dt equals, and that's really what we want to find. So we're just putting a question mark beside that just now. And we're also told that the radius is 3, or r equals 3, so you can write that down as well. So we're putting down just everything that we know. Once you do that, before you move on with the problem though, take it a little further. See if there's anything else you can work out. Well, from r equals 3 you can't, from dv by t you can't, from dr by dt again you can't work anything out. But because we're told v in terms of r, what we can do is, you got it, we could differentiate. If we differentiate v with respect to r, well, that would give us dv by dr. And that would equal, well, if you bring the 3 down, you'd have 12 over 3 pi r squared, and that would just become 4 pi r squared. So we also have the formula for dV by dr. What we then want to do is think about what we're wanting to find. Well, we want to find dV by dt. So now we need to create a formula for dV by dt. So the way we do that, once again, we think dV by dt equals, and then split this up. So that'll be dV by d something times d something by dt. And what we want to do is we want to put the same thing in place of the star. It's going to be d something and then d something, but it has to be the same thing. Look at the rest of the problem to see what you have. Well, because you've got a formula here for dv by dr, and you've also got dr by dt equals 2, why not make that other letter r and see if that works? So you can say then that dv by dt would equal dv by dr, put a dr in here, and then you'd have to put dr in here, so that would be dr by dt. If you do that, then dv by dt would equal, well, do we know what dv by dr is? Well, yes, we do. It's this 4 pi r squared. So that's 4 pi r squared. And we're multiplying that by dr by dt. And dr by dt, if you look up here, well, that's 2. So we can swap that with 2. From there, tidy that up. Well, 4 times 2 is 8, so we've got 8 pi r squared. And really, we're wanting to work out the rate of change of v when r equals 3. So we know that r equals 3. So we can say then that dv by dt would equal, and then replace r with 3, so we'd have 8 times pi times 3 squared. That would give you 9 times 8, which gives you 72 pi. So that there would be your answer. Example 2. The radius r of a circle is increasing at a constant rate of 3 centimeters per second. Find the rate of change at which the area of the circle is increasing when the radius is 13.5 centimeters. Once again, for any of these problems, what would you do, Jeremy? Good, you just write down what you know. So read the question and take the information that you can from that. So the radius of a circle is increasing at a rate of 3 centimeters per second. Because it's per second, it means that the radius is changing depending on what the time is. So in other words, that is dr by dt. And we know that's equal to 3. So the radius is changing depending on the time, and that would equal 3. Find the rate of change at which the area is increasing. So what we want is dA by dt. So we can just put a question mark beside that. When the radius is 13.5, so we know the radius equals 13.5. Is there anything else that you could get from that question? Well, if you read it, think about the shape that you have. So it's telling you the radius of a circle. Because it's a circle, and because it's talking about the area, well, you know it's the area of a circle. That's going to be involved somewhere. And you know the area of a circle is pi r squared, so you can write that down as well. Again, think, is there anything else you can work out? So you can't work anything out here or here or here, but because you've got a in terms of r, you could differentiate a with respect to r. So we can say dA by dr equals, and then if you differentiate this, just bring the 2 down, so you'd have 2 pi r. So that is us armed with all this information. So can we now find dA by dt? Well, the first thing we do is we create a formula for dA by dt. And if we do that, what we're going to say is dA by dt equals, and then split it up. So that will be dA by d something times d something by dt. Again, in place of the star, you have to have the same thing. So look at what else we are told. We have the information dr by dt. We've also got dA by dr. So r is another letter that appears here. So why not make it dA by dr times dr by dt? See if you can put in enough information here in order to answer the question. So dA by dr, do we know what that is? Well, yes, we do. We know that is 2 pi r. So we can replace that with 2 pi r. dr by dt, do we know what that is? Well, yes, we do. We've got dr by dt and we know that's 3. So we can replace that with 3. After that, tidy that up, so that'll just give you 6 pi r. And now we've got a formula for dA by dt, and it's equal to 6 pi r, but we know that r, the radius, is 13.5, so we can swap r with 13.5. Doing that will give us 6 pi times the 13.5, which works out to be 81 pi. Because here we are told the units, we need to think about the units. So what would the units be? Well, it's the area that is changing, and the area is measured in, well, because it's mentioning centimeters up here, it'll be centimeters, and then you've got squared, so it's squared centimeters, and that is going to be per second. So the time is measured in seconds. So we'd have 81 pi squared centimetres per second. Example 3, the side length x centimetres of a cube is increasing at a constant rate of 1.5 centimetres per second. Find the rate at which the volume of the cube is increasing when its side is 6 centimetres. Once again, for any of these problems, write down what you know. So go through the problem. The side length x, so we know the length is side x, so that's what we're picturing, of a cube is increasing at a constant rate of 1.5 centimetres per second. So we know the length is increasing depending on the time. It depends on the time. So we know then that we can write that down as dx by dt. And that is equal to 1.5. Find the rate at which the volume is increasing. Well, if the volume is increasing, again, it's with respect to time, so we can write that down as dv by dt. And that's equal to, well, that's what we want to find. We're also told when the side is 6 centimetres, so we know the length of the side is 6, so we can say that x equals 6. Again, think, is there anything else you could work out? Well, here is talking about the volume of a cube. How do you get the volume of a cube? Well, it's length times breadth times height. But because, Mary Lou, you're perfectly right, yes, because you've got x times x times x, you could just say that that would be x cubed. That is what the volume will be. Again, just think, can you take that any further? Well, you cannot take this further, you can't take this further, you can't take this further, but here v is written in terms of x, so you can differentiate v with respect to x. Doing that will give you 3x squared. So we are now armed with all this information, and we have to work out dv by dt, so we need to create a formula for dv by dt. So once again, you are thinking this is a related rates of change problem, so you're going to say that dv by dt equals dv by d something times d something by dt. We need a different letter in here though in place of the star, so what could we use? Well, looking at the other information, other letters that we have, well, we've also got x's as well. So we could make this dv by dx and then dx by dt. And really we would do that because dv by dx, we know that is 3x squared. And also dx by dt, we know that is 1.5. So that becomes the 3x squared times 1.5. 3 times 1.5 is 4.5, so we've got 4.5x squared. And then after that, we know that x equals 6 centimetres, so we can replace x with 6 centimetres. So when x equals 6, then dv by dt will equal the 4.5 times 6 squared, which equals 162 cubic centimetres per second. Yeah! Example 4, the radius of a sphere is increasing at a rate of 2.5 centimetres per second. Find the rate at which the volume of the sphere is increasing when its radius is 8 centimetres. Are you ready? Let's go! So we write down everything that we know. So what do we know? Well, the radius of a sphere is increasing at a rate of 2.5 centimetres per second. So it's the rate of change of the radius with respect to time. So that is dr by dt. And that is equal to 2.5. We can write that down. Find the rate at which the volume is increasing. So it's looking for the rate of change of the volume, again with respect to time. So dv by dt is what we want. And we're also told the radius is 8 centimetres, so the r would be 8 centimetres. Again, it's talking about this sphere. The sphere is going to be increasing. Well, we know the volume of a sphere is 4/3 pi r cubed, so we can say that v equals 4/3 pi r cubed. Again, is there anything else you could work out? Can you take anything further? Well, you can't with this, but v is written in terms of r, so you could work out dv by dr by differentiating the volume with respect to r. So that would equal, bring the 3 down, so that would cancel with the 3 in the bottom, so you're left with 4 pi r squared if you differentiate that. Again, think about the problem. We're wanting to find dv by dt, so we're going to create a formula for that. So you're going to say dv by dt equals dv by d something times d something by dt. Again, the best way to think about it just now is that these two would cancel, leaving you with dv by dt. What letter could we use? Well, what else do we have in the question? We have a dv by dr, we have the r equals 8, we've got dr by dt, so we also have r, so why not make it dv by dr times dr by dt? If we do that then, well, dv by dr, do we know that? Yes, we do. dv by dr is 4 pi r squared, so we can sub that in there. dr by dt, what's that? Good, that's 2.5, perfect, so we can put that in as well. Tidy that up, Sahana, what do you get? Good, 10 pi r squared, well done, Sahana. And after that, what do? Good, you replace r with 8. We know the radius is 8 and it's asking us for the rate of change of the volume when the radius is 8. So because r is 8, you can swap that in. So we'd have 10 times pi times 8 squared, which works out to be 640 pi. And again, just remember your units, because it's talking about volume, it'll be cubic centimeters, and because it's changing with respect to time, it's going to be per second. So your answer, 640 pi cubic centimeters per second. Woo! Well done. Example 5, air is blown into a spherical balloon at a rate of 160 cubic centimeters per second. Find the rate of increase of the radius, r, when the radius is 5 centimeters. Once again, what do you do with these, Max? Good, you write down what you know. So Max, what's the first thing you know? Brilliant, you know dv by dt. Read the question. Max is just getting it from here. Air is blown into a spherical balloon at a rate of 160 cubic centimeters per second. Because it's blown in at that rate, well, it's 160 cubic centimeters, which is going to be the volume. So the volume is going to be changing. So it's the rate of change of the volume with respect to time, s is for seconds, that we have. So dv by dt would equal 160. Keep on reading the sentence. We'll find the rate of increase of the radius. So that's what we want to find. We want the rate of change of the radius. So dr by dt is what we want. So just now we can say that equals, and then just put a question mark. If you keep on reading, well, it says the radius is 5 centimeters. Write that down as well. And again, think about this. Because it's a spherical balloon, we know the volume of a sphere is given by 4/3 pi r cubed. So we can say the volume, which this question is all about, is equal to 4/3 pi r cubed. Taking that further, what could you work out? Well, because here the volume is written in terms of r, you could differentiate it with respect to r. So you can say dv by dr equals, what would that equal, Jenny? Brilliant, that would equal 4 pi r squared. Fantastic. After that, where do you go? Well, you want to create a formula for, good, dr by dt. That is what you want to find. So you can say then that dr by dt equals, and again to split that up, so it's dr by d something times d something by dt. From this, you're going to have the same thing where the star is. So what could you use? Anybody have any ideas? Perfect, you could have v thrown in there. So you could make that dr by dv times dv by dt. You need to look at this information that you have. And the reason you're using v is because if you have to work out dr by dv, well, we don't have that, but what we do have is dv by dr. So if you think about it just now, 4 pi r squared is the same as 4 pi r squared over 1, and that is dv by dr. But because you want dr by dv, well, you could flip that upside down. And if we flip that upside down, that's the same as flipping the 4 pi r squared over 1 upside down as well. So really, dr by dv will be 1 over the 4 pi r squared. Also, dv by dt, what is that? Well, it tells us up here dv by dt is 160. So we can swap that with 160. From there, well, if you tidy that up, that will just be 160 over 1. So multiply the numerators, multiply the denominators, and that is what you would end up with, 160 over 4 pi r squared. But you could obviously tidy that up. So really you end up with dr by dt equals, and you'd have 40 over pi r squared. Where do we go from there? Does anybody have any ideas? Brilliant. What you can do is, you know r equals 5, so replace the radius r with 5. Therefore, dr by dt would equal 40 over pi times 5 squared, which is going to be 40 over 25 pi. And if you tidy that up, Carol, you end up getting, good, you would get 8 over 5 pi. And once again, just remember your units, because it's the radius that's going to be changing with respect to time. Well, the radius is measured in, it's going to be centimetres here, so it'll be centimetres per second. And that there, the 8 over 5 pi centimetres per second, will be your answer. High five! Well done. Example 6. A spherical balloon is being inflated. When the radius is 10 centimetres, the surface area is increasing at a rate of 120 pi squared centimetres per second. Find the rate at which the volume is increasing at this moment. And we are told the volume of a sphere and also the formula for the surface area as well. So this is given. So we need to write down what we know. Well, obviously we know the volume and we know the surface area formulas. But what else do we know? Well, the spherical balloon is being inflated. Great. And we know when the radius is 10 centimetres, the surface area is increasing at a rate of 120 pi squared centimetres per second. So from that sentence, it says the radius is 10 centimetres. So write that down. Just go through it and pick out what you know. Because the surface area is increasing at this rate, well, it's going to be the rate of change of the surface area. I'm just going to write down A. So that'll be dA by dt. And that is equal to 120 pi. Num num num. So find the rate at which the volume is increasing. Well, because we want the rate of change of the volume, that will be dV by dt. And that will equal, well, we don't know yet. It's what we want to find. Anything else you could work out from that? What do you think, Kier? Brilliant, you're perfectly right. Because you have V written in terms of R, and because you have A written in terms of R, we could differentiate them both with respect to R. So you could also work out a formula for dV by dr. What would that be, Kier? Good, well done, 4 pi r squared. And if you had to work out dA by dr, if you differentiate A with respect to R, that would be brilliant, well done. After that, well, you're wanting to create a formula for dV by dt. So you can say then that dV by dt would equal, and again you're splitting that up, so it's dV by d something times d something by dt. What letter could you use? Well, if you look at the rest of the information, what are you going to have? Well, we've got here dV by dt, that is what we're wanting to find. We've got a dV by dr, well, I suppose we could use that, and then we would need, though, a dr by dt. We don't have an awful lot of choice here, so let's put in just now dV by dr times dr by dt. Well, that means that would equal dV by dr is just 4 pi r squared, that's great, we know that, but dr by dt, we don't know what it is. Dun, dun, dun. So we don't know dr by dt, but what we can use is the other information to do with the surface area and so on, in order to work it out. So let's go over the page and do that. So above this pink line is what we have already, just on the last page. We've got all this information. We were writing down dV by dr times dr by dt, and we came up with 4 pi r squared times dr by dt. But because we don't know dr by dt, we need to use this other information. Well, the other information that we have, we're told right away in the question dA by dt. So how about we write down a formula for dA by dt? What we can say with that is it's dA by d something times d something by dt. And because we've got this dA by dr, how about we use that? So we can say then it's dA by dr times dr by dt. And if you replace everything that you know here, well, you will end up with, well, dA by dt is 120 pi. Boom, just bang that in. dA by dr is the 8 pi r. Boom, bang that in as well. And dr by dt we don't know, but that's what we want to find. That is our missing piece of the puzzle, so we now know what dr by dt is if we rearrange this. So we can say that dr by dt equals, divide both sides by 8 pi r, so we'd have 120 pi over 8 pi r, and that would equal then 15 over r if you simplified. pi's would cancel out, and then 120 over 8 would give you 15. We'll still get this r on the bottom. Because we know now dr by dt, we can sub that into the original equation that we came up with. So we go back up over here, and we replace dr by dt with the 15 over r. Therefore, we will end up with 4 pi r squared times that 15 over r. Work that out then. Well, 4 times 15 would give you 60. R would cancel out here. It would leave you with one of them here, and we've still got pi, so we've got 60 pi r. And to finish off, well, we're told to work it out when r was equal 10. So because we know r equals 10, we can sub that in as well. So you can say then that dv by dt would equal 60 times pi times r, which is 10, which works out to be 600 pi. And because it's the rate of change of the volume, well, remember it was measured in centimetres, so it'll be cubic centimetres. And because it's with respect to time, it'll be per second. So you have an answer of 600 pi cubic centimetres per second. Yes. Example 7. Sand runs into a conical tank at a rate of 5 pi litres per second. The tank stands vertex down, as seen here, and has a height of 4 metres. And a base radius of 2 metres. Find the rate at which the depth of the sand is increasing when the sand is 1 metre deep. Boom, boom, boom. So Naomi, what would you write down first of all? dv by dt. Perfect, you would write down dv by dt. And you write that down because if you read this sentence once again, you are told that the sand runs into a conical tank at a rate of 5 pi litres per second. If you think about that 5 pi litres, well, that's going to be the volume that is in the tank. So because it's talking about the volume and it's changing with respect to time, you can say that as dv by dt, and is equal to 5 pi litres per second. With this, we are best to write our litres in cubic centimetres, so we know that the 5 pi litres is the same as 5,000 pi cubic centimetres. Again, if you read the question, when we know this cone, it's got a height of 4 metres, it's got a radius of 2 metres, and what we want is the rate at which the depth of the sand is increasing. Because it's talking about the depth of the sand, well, that will be the height of the sand that's in it. And that will be changing again with respect to time. So dh by dt is what we want to find. We are wanting to find it when there is a height of 1 metre of sand. So we know the height is going to be 1 metre, and again, I'm just going to put that into centimetres. And what else do we know? Well, because it's talking about the volume of a cone. Rory, what's the volume of a cone? Good. Volume of a cone is 1/3 pi r squared h. So we also know that as well. What we want to do is find out dh by dt. So we want to create a formula for dh by dt. Therefore, we are going to say that dh by dt equals, and then we're going to split that up. So dh by dt equals dh by d something times d something by dt. And the something has to again be the same letter. What letter could you use here? Well, you don't have an awful lot of choice. We've got dv by dt, so we could always put dv by dt in, which would mean we would need dh by dv. So if we put that in, we've got dh by dv times dv by dt, which is fine because we've got this at dv by dt. We know that is the 5,000 pi. But dh by dv, well, we don't know what that is. So we've got an issue with the dh by dv, or if we flipped it upside down, even dv by dh. dv by dh would be when we differentiate the volume with respect to h. However, dun dun dun, if you look at the formula for volume, there are 2 variables. You've got r and you've got h, and both of these will be changing. So what we need to do is we need to rewrite the volume just in terms of one variable. But because we're wanting to work out dh by dv, or upside down dv by dh, what we need to do is we need to rewrite it just in terms of h. So what we need to do is we need to rewrite r in terms of h, and then we can simplify that. So let's abandon this for the meantime, and let's work out what the r would be in terms of h. So we are told that the volume is equal to 1/3 pi r squared h. But we can see here that this cone that we're given in the question has a height of 4 meters and a radius of 2 meters. So right away we know that the height of the cone is double whatever the radius is. So we know the height equals 2 times r. Because we know that, then we can write down what r would be. And if you divide both sides by 2, well, r would equal h over 2. So because we know the radius is equal to h over 2, we can sub that back in to this formula here. So the volume equals 1/3 times pi times r squared times h. Replace r with h over 2. So you would have 1/3 times pi times h over 2 squared times h. Multiply that out. Well, if you're squaring the h, squaring the 2, that would give you there an h squared over 4. And if you tidy that up, you end up with 1/12 pi times h cubed. What was the whole point in doing that? Well, if you remember, we had to work out dv by dh. So now we can work out what that would be. So dv by dh, if we differentiate v with respect to h, so dv by dh would be 1/4 pi h squared. dv by dh is what we have just found. So with all of our information that we wrote down at the very start, we can now add dv by dh to that. If we go back to the original equation as well, we had dh by dt equals dh by d something times d something by dt, and it was dv that we decided to put in. So we've got dh by dt equals dh by dv times dv by dt. We now need to sub both of these in. So dh by dv, what is that? Well, if you think about dv by dh, that's 1/4 times pi times h squared. Because we've got 1/4, really we're dividing the pi h squared by 4. So instead of thinking it's 1/4 times that, just put in divide by 4. That is what dv by dh is, but if we want dh by dv, well, we're flipping that upside down. So we're also flipping this upside down as well. So that will give us 4 over pi h squared times by, and dv by dt is the 5,000 pi. So we can put that in. From there, imagine 5,000 pi is 5,000 pi over 1, so you've got the two fractions, multiply the numerators and the denominators, and we end up with 20,000 pi over pi h squared. You have a pi in the top and a pi at the bottom, so you would cancel! And if you cancel them, you end up with 20,000 over h squared. We know that we were writing everything in terms of centimeters, so 1 meter is what we're asked to find, which is 100 centimeters. So replace then h with 100. If we do that, we will end up with 20,000 over 100 squared. 100 squared is 10,000. Good, so it's 20,000 over 10,000, which works out to be 2. And because it's the height that is going to be changing with respect to time, well, the height is measured in centimetres and the time was measured in seconds, so it will be a rate of 2 centimetres per second. Try these questions in the Unit 2 booklet. There's quite a few on page 56. Check your answers as you go. Good luck with the related rates of change 1, explicitly defined rates. Woo! Enjoy!